Hey guys, in this video, I'll walk you through an FRQ from AP Classroom. So in this question, we're given the graph of some function g, and we're told that it's closed in the interval from -4 to 8. And looking at the graph and the question, we see that g consists of two linear pieces and a semicircle. We are also given a function f, which is 3x plus the integral from 0 to x of g of t dt. And in part A, we're asked to find f of 7 and f prime of 7. We'll start off by finding f of 7. We're given the definition of f of x, so we simply plug in 7. And we get 3 times 7 plus the integral from 0 to 7 of g of t dt. Now, how do we find this integral? We know that the integral is simply the area under the curve, so we look from 0 to 7, and we want to find that area. Now notice that area consists of two pieces, a semicircle and this rectangle. And since this semicircle is under the x-axis, we would subtract that area, and since this rectangle is above the axis, we would add it. So we can see that f of 7 is just 3 times 7 minus the area of this semicircle, which is just 1/2 pi r squared, which is 3, plus the area of this rectangle, 1 times 3. And when we simplify that, we see 24 minus 9 over 2 pi. Now we'll take a look at f prime of 7. Since f of x is just the sum of two parts, we can individually take the derivative of each section. We know that the integral, or the derivative of 3x is 3, and using the fundamental theorem of calculus, we can say that the derivative of the integral from 0 to x of g of t dt is just g of x. Now we want to find f prime of 7, so we simply plug in 7. We can look at the graph and see that g of 7 is 3, so we plug in 3, and we find that f prime of x equals 6. Now let's take a look at part B. We're asked to find the value of x in the interval from -4 to 3, where this function f has its maximum value. Now we can take a look at the derivative of f of x to get an idea on where the maximum could be. We know that we need to find in the interval from -4 to 3, so we can mark those 2 points. And now we can find the derivative of f of x. From the previous slide, we know that f prime of x equals 3 plus g of x. So the derivative is 0 when g of x is -3. And this is true when x is 3. Because then y is -3. So we can mark that on our graph that at x equals 3, the derivative is 0. And now we can test the points in this interval to see if the graph would be increasing or decreasing. You can see that for any point less than x equals 3, g of x is greater than -3. So in the interval, the derivative would be positive, meaning the graph increases. So since the graph increases from -4 to 3, we know that the maximum value must occur when x equals 3. So the value of x, where f attains its maximum, is 3. Now let's look at part C. We're asked to find both the left and right-hand limits of g prime of x. Looking at the graph, we can start off by finding the left limit. You can see that for every point before x equals 0, the slope is constant and -1/2. So since every point leading up to it is -1/2, this limit must be -1/2. Now what about the positive limit, or the right-hand limit? if we follow this circle and see what the tangent approaches, you can see that it approaches a vertical line and it leads upwards. So this limit is positive infinity. Now let's take a look at part D. We're asked to find the limit as x approaches -2 of f of x plus 7 over e to the power of 3x plus 6 minus 1. We can start off by finding f of -2. And we see that it's 3 times -2 plus the integral from 0 to -2 of g of t dt. Now, this is the same thing as subtracting the integral from -2 to 0 of g of t dt, if we just flip the limits and flip the sign. Now we can find this integral because we want to find this area here, the area under the curve. We see that it's simply just a triangle, so we can say 1/2 times the base and the height, and we see that f of -2 is -7. Now, if you plug in -2 in the denominator, we see e to the power of 0 minus 1, which is also 0. So we end up getting this 0 over 0 indeterminate form. So now we have to use L'Hopital's rule and differentiate the top and the bottom. By differentiating the top, we see that the derivative is simply f prime of x. And when we do the same to the bottom, we see that the derivative is 3 times e to the power of 3x plus 6. So we can plug in these values, and we can see that this limit is the same as this limit. Now we have to just plug in -2 and see what we get. We know that f prime of x equals 3 plus g of x from our previous examples. And when we plug in -2, we can see 3 plus g of -2. And since g of -2 is just 1, f prime of -2 is just 4. And when we plug in -2 to the denominator, we see e to the power of 0 here, which is 1. So we get 4 over 3. And we found this limit using L'Hopital's rule and these derivatives. If you liked this video and found it helpful, please remember to leave a like and subscribe. And if you have any questions, you can leave them in the comments below and I'll get back to you as soon as possible.